Good morning, everyone. It's a pleasure to be here with you. So my name is Cainã. I'm a postdoctoral AI engineer at UW Madison in Wisconsin. I'm from Brazil, so I can realize some accent. And today I'm going to discuss about that's the goal of our presentation today. How do maybe too big. But basically going to build a line graph agent, a graph that we can have a main router. So the user is going to ask some question about the database, about something else, and hi, greeting. And then we're going to route this query, classify the intent, the user intent, and based on the intent of the user, if something about the database, you're going to follow the SQL agent path. So you're going to generate the SQL. In case like successfully generated, you're going to validate the SQL. Here you're going to use PostgreSQL engine. We validate if there's any kind of word here, so to have any kind of drop update statement, not going to allow the user to execute it and to move forward. It's going to just show in the query and show the message to the user. Going to assess if like the syntax is valid. Also using like built-in PostgreSQL functionalities, and also have a human-in-the-loop approach where it asks for the user to say if you have to confirm if they want to execute it or not based on the generate SQL query, and then it executes it, interprets it, and provides the answer to the user. On the other hand, if the question is not related to the database directly, it's going to support to provide some friendly message to the user and provide some kind of tools they can use, like friend message and also, okay, I am a SQL agent, how can I assist you today? And I have following tools, for example, provide like detailed explanations and getting the most similar SQL examples here as well. So because here we're going to use a RAG approach. So how many of you are familiar with RAG concept? Almost everyone. Okay. There's a quick recap for those not familiar with it. It stands by retrieval augmented generation. So in this context, you're basically retrieving some information. For here, I'm going to retrieve the SQL examples. I'm going to populate the database with like SQL queries and expected SQL code, and I'm going to find the most similar examples according to the user query, and I'm going to augment the original prompt so they can have an extra knowledge and can improve the accuracy of the model. So basically, that's how I'm going to do it. So in order to run this tutorial, what you need here, I have provided some prerequisites to install. Not sure if you have been able to do it. Basically, that's Git. I need to clone the repository. You're going to use UV. UV is the pretty fast Python package manager. So it installs Python for us, the correct version of Python, all the dependencies, pretty fast. So here I have the code. And you're going to need at least the binary version of PostgreSQL to be able to access the database. So for Mac and Linux, quite easy to install. Like for Windows, please follow the instructions. And Docker is optional, so I don't need to have it right now, but it's good. So as a Python IDE, I'm going to use Cursor, but feel free to use VS Code, Cursor, Windsurf, whichever Python IDE you prefer. And here you need to make sure that all of these running okay from your side. We're going to do it quite easily. So one thing that you can start doing right now is like trying to clone the repository, then you go from there. I think you can do it together, so we can Is it okay for you if you follow along together? Okay. Okay, so that's the thing here. So I think my repository is up to date. Okay, just one thing here. But okay. One prerequisite that I forgot to add here, it's good to have, not monitor as well, but if you want to inspect the database, you can have any kind of ID to connect to the database. I'm using the Beaver. It's quite easy to install if you want to try it. So I can also visually inspect sorry, the database here. So let's do it together here. So let me edit connection. I need to share extra information with you. So I have the database hosted on AWS. So I can just provide I need to provide the host, database name, username, and password. I have shared the username and password to the Slack channel. I'm going to provide the host and database credential as well, so I can use it directly. And I'm going also to share a temporary OpenAI key with you, so I can use it. So give me a moment, please. I'm going to edit this message here. It's easier. So for any SQL ID from your preference, you can try to connect it to inspect it directly, the database that you have. So you need to provide the host, the database name, the username, that's SciPy 2025 for our view, and have the same password that is shared on Slack channel. So you can test it out just to make sure it's going to work. It's all in Slack. Meanwhile, I can show you the database that you're going to work with. So for building this example, I'm going to use a database called Brazilian E-commerce Public Dataset by OList. OList is a company, a e-commerce company from Brazil. They have provided this dataset a long time ago. That's one of the most famous datasets to play around with SQL. It has using this main dataset with another subset they provided, so it can work together. So it's going to have two main schemas, one with 9 tables and another one with 2 tables. Even though I'm not going to focus so much on the database itself here, I'm going to focus on the implementation of the SQL agent. So here we have the schema for the database. So I have information about reviews, information about orders, about payments, customers, items, and so on. So that's the relationship that we have. And I have created this database and made it available, public available for you on AWS with all foreign keys, our schema correct set it. So we have the database, we have the indexes, we have the foreign keys, and so on. You're going to leverage to automatically generate the schema directly from the database. So that's one, and that's the second one. We have some extra information about a funnel marketing schema here. So that's what I have, basically. Could some of you be able to connect to the database? Okay, that's cool. And please, feel free to stop me and also to ask help of the friends that could made it. Yeah, did it work? Sorry. Okay. So it's on Slack here, the database name and everything. So all list e-commerce here. And let's start building together. So even though I have the whole code, I have structured this tutorial to work mostly with notebooks. The code is, oh, please. Oh yeah, I recommend you to download this IDE here called the Beaver. Let me show the link here. The Beaver. I'm going to share in Slack so I can install and I can show how to connect with you. So that's the only missing part of the prerequisite. Sorry, I forgot about it. So database ID. So you can download it. It's quite straightforward. That once everyone has downloaded it, I can showcase how to connect it, how to create a new connection here. I can even exclude this connection here and do it from scratch again. Okay. And let's showcase this application. This tutorial not going to show integration with Slack, integration with UI, for example. Just focus on the API creation, like the code, the background, the LangGraph code, and the background creation. But based on that, and since it's modularized, we can connect to any kind of UI. You can connect to Slack, you can connect to Streamlit, to person like custom UI, and so on. I can showcase how it's working for you here. That's like of my work. So basically, one thing that you can do, at my work at UW, our research tries to combat, reduce the Amazon deforestation in Brazil. So I have a really huge and unique database where I have a lot of information about farms, cattle transactions, and so on. So, and I have just a few data engineers. That's a small lab, a few data engineers with huge workload. So we came up with this idea to develop, to promote accessibility of the database by stakeholders and also including prosecutors and domain scientists that doesn't know how to code in SQL because that's not the goal in their expertise. So what we can do basically is just asking some questions, and just asking some random questions here. I was testing before. So if it's going to detect that's a question about the database, and it's going to reply here, hopefully. So it replies with the SQL code that we're going to build together today, the logic for it, and also provide if you want to execute or not. So let's not execute that right now, and that's fine. So let's try something easier to not overcompute it. So it generates a very simple query here that appears to be correct. So let's execute it. And then it provide the answer for it. It executes, provide the answer, and so on. In this meantime, it also validated the syntax and also some safety measures about the SQL generated. It has a built-in memory. We're also going to work with memory, also based on PostgreSQL. So the memory is based on the section, and the session is based on the thread. So every time I mention the bot, they're going to start a new thread, just like a new conversation in ChatGPT. And everything here is like, it's in memory. So for example, what about PA, that's the state of Pará in Brazil. So what about Pará? Probably either it should recognize, provide the same question, the same query, but now for Pará. You can also execute it or not execute it. And also recognize random text. If I say, hi, it's not going to provide any SQL, right? It's not expected to provide any SQL. And you can also have some further tools, for example, to better explain it, and also to show some similar queries on the annotated SQL database that have vector stores. So what are the most similar queries to deforestation? So in this case, it's using a tool, so let's see how it's going to work. Okay, so I provide like some examples of the annotated SQL they have. So basically that's what I'm going to be building today, right? So, but not with like integration because like too much right now, but let's go for it. So have you downloaded dbeaver? I mean, or if you have like a connector to the database. Okay. I mean, with this ID, you can connect to whichever database you want to, but for this tutorial, now you need to connect to this one. Yeah.
It's connected to the database, but it's not showing any tables under the e-commerce.
Oh, really? Read timeout? Okay, let me try to do it with you so I can like. You. Okay, okay. So. Okay, probably the permission. So let me. That's quite fast. So let me do something. It's not the best practices, but let me update the username and possibility. So that's to make sure it runs smoothly. I'm going to share with you another credential with the admin privilege. So just don't create a table. So it's also a temporary table. So after the tutorial is going to be that. So use carefully. Oh, it's not here. Mm-hmm. Okay, I'm going to update once again the message. Then you need to edit the connection. Okay, I'm going to. And I'm going to connect with you. So let's see if it works. Great. So, oh, I updated wrong. I'm sorry. It was supposed to be here and. It's working? Yeah. Okay, perfect. I just need to recover the IP because I forgot from myself. I need to put the instructions here. Okay. Okay. So let's try it again. So basically, you create a new connection. There's a PostgreSQL connection. So if everyone hasn't done it yet, so let's do it together. So new connection, PostgreSQL connection. Next, if the first time you're using it, probably is going to require installing some plugins. Just install it, please. On host, you're going to provide a public IP from the AWS machine I have provided. For the database, like olist, e-commerce. Username is Postgres and password is the one on Slack. So just copy and paste it here. You can test the connection before connecting. So, okay, apparently worked good. And then you can inspect here. So schemas, e-commerce, tables. Okay, you have the tables here. Marketing, tables. You also have it here, right? So everyone's good. Everyone needs help at this stage. Okay, so let's move forward. So again, I'm using Cursor as an ID, like a VS Code based ID. So I can use VS Code or any ID you want to. Since you have cloned the repository, git clone repository, and entered repository, you shall see exactly this structure here. Yeah. Let me see. Is it better, or should I just need more? It's okay. Yeah. Yeah. I mean, like this midterm here. Questions? For the same Postgres? Okay. Okay. So far, I'm not going to use it. So in the break time, I can come to your computer and help you out. Okay. Good. Thanks for letting me know. Anyone else with the same issue? Okay. So the first thing that I'd like to ask you to do right now is to go to the configs folder. In this configs folder, I have a database.yml file here, and just going to ask you to replace these values by the values that from Slack. So basically, it's like you need to replace localhost, and also you need to replace password here, because I was running locally. In case you want to run locally, you can, for development, you can use these specs here. Just need to set up the database. So host goes here. Password goes here. And okie dokie. This file shouldn't be. Is it mine? Oh, sorry. Yeah. So usually that's just to let you know, it's not the best practice as well. Please don't store password in YAML file, and most important, don't push it to the Git repository. Okay. So usually for Postgres, you have this kind of special file called like .pg Postgres on the home user, or you can use this provided directly from the environment file that I'm going to provide here. And by the way, let me share the OpenAI key with you as well. Let me share in Slack. Use consciously is going to stop being valid after the tutorial. but even so. Right. Basically, one thing that you can do is like copy the .env example to .env here. Then you're going to provide the example of the environment that you're going to need to use. And then we can replace some these values here. Yeah. I'm also going to update my env variable with the credentials here. Do it. So once it's done, we can start like exploring, understanding a little bit the folder structures here that I have provided. It might look like too much, but you're going to go for it. And I also have like, I structured these notebooks. Basically, if like, this nomenclature here, this pattern called 0.0, that's implementation without leveraging modularization, just like we're going to do it, working a little bit right now. And then we have a higher number, kind of a version number of the file here. And then we, in this case, we also started using modularization. So always we see here 0.0 is the simplest way without taking leverage of the project modularization. And now, so higher versions usually means you're going to use it. Basically, it's like a bunch of copy and paste. That's how we do it in projects. Usually, like at least I do it on notebooks. I start exploring the notebook, and then I can start copy and paste for the Python files and loading the functionality directly, because otherwise it would be like a really huge notebook, and notebook's not good for production. So, so let's start it directly. So. I think you can start directly with the database connection. So, just to let you know, so what kind of IDE you are using? Like any kind of VS Code-based IDEs? You all? Okay. So I'm going to use Jupyter notebooks inside the IDE. You can do it whichever way you want to. In order to it work, you just need to install the Jupyter extension here, Jupyter. And it's going to work. And another important step is once you have installed UV, you just run UV sync. This command here, UV sync. And UV sync is going to install Python all required packages automatically pretty fast. So including the kernel, the library for running this project here. How many of you are familiar with UV? Okay, so since there are, so UV is, just starting for the ones that are not familiar, UV is like a faster way to manage Python project management. It's just like Poetry. Not sure if you have heard about Poetry, but it's a modified version of Poetry. Basically, instead of having the requirements.txt, we have this nicer pyproject.to file, and we provide here a bunch of metadata about the project, and also the dependencies here, and I can also have some linting rules and so on. So I'm using UV because it's fast. Poetry is going to work basically the same way here. And also using Roof for linting the project. Links is like to make sure the project have its standards, so like everyone can understand it. Your future yourself, the future yourself can understand it as well. It's all from the same company that have created. The same company have created. UV has also created Rough, so it's based on Rust and extremely fast. So you're going to do it here. It's all set up for us, but that's the entry point of our project. So if you want to add a dependency, you add here. If you want to remove a dependency, we add it here. If you want to change the patterns about the doc style, here I'm using Google doc style for docstring. It's also here, and so on. So that's entry point. And what UV sync does is basically it not only installs the dependency, but it also removes like extra packages. So it syncs with the PyProject file. If you don't have anything extra, is going to be removed. Anything missing is going to be installed. And it's also going to use the specific Python versions that I have provided here. So UV sync, it worked for all of you? Okay, good. Okay, so I have the repository, have the database that's up. We can start like trying some connection and trying developing the application. So one thing that I asked you to do, like to clean output. Let's try to do it together if you want to. Like the run version is on GitHub anyway. So usually for every notebook, I'm going to have this cell here. This because to simulate, I'm running the script from the root folder. That's why I have this code here. Not anything else. And one package that you can create, you can connect to the database, you can inspect the database, retrieve documents, and so on, is SQL Alchemy. So it's a very common package on Python for connecting it. You're going to use it for inspecting the database automatically. So for our text-to-SQL agent that you're going to use LangChain, LangGraph, we are extracting all the schema using SQL Alchemy. You're going to populate the schema. So far, it's like a static schema because you don't have too many tables. So you're going to organize it. I'm going to show it right now. I'm going to organize it. But the idea, the goal here is to populate the system prompt with the information about the database schema, so the large language model can understand how to create the code for our specific database. So one thing that you can do here, so far hard-coded, but ideally you should retrieve it from the .env files. But again, that's just the first implementation. Just start working with the project in a simulation. So what you need here to update the string, to not use a local host, you need to use the actual host from AWS. So let's do it here. Replace localhost, and should also replace use. No, not the user. That's fine. And the password. Yeah, the password. So the password here is going to be this. Okay, and it worked. So that's the first symptom that our connection to the database worked, right? So please let me know if it works for you as well. I just need to update these here, specifically update you see the pattern here, like user, keep the user, update the password, update the host, everything should be the same. And just connecting, selecting one, it worked. So one way to inspect the database is like using inspector engine from SQL Alchemy. So basically, we just like you need inspector and get tables and specify the schema you want to inspect. From this case, we know the schemas that we're going to look for. We're going to look for e-commerce and marketing. So we have like 9 tables here, 2 tables here. So let's test it. And here you are. So That's the table for e-commerce, and those are the tables for marketing. So what you need to have is like create the tables for the schema for all of these tables here. If you want to expect, for example, a specific table, so let's say you want to expect like the geolocation table from the e-commerce schema, then you use a method called getColumns and can expect from the table in the schema here directly. I can run it here just to make sure and convert it to Python data frame and print it. So that's the table that we have. And here we have some information about us. This table has these columns, these types, data for every column has a data type. It can be nullable or not. And it has some further metadata that we don't care for this particular application. But one important application that the way I set up this project is I'm providing comments, and that's the one of the biggest difference, like advantage of this tutorial, of this approach specifically, is that you're not going to only retrieve the table names and column names. You also provide domain knowledge about the schema. And how are you going to do it? We're going to do it. I can do it manually. You can do it different ways. But one way that I have talked to the data engineers, for example, to do it in the real case, is like providing comment to the database directly. So you can just look for the columns with comments. You're going to use comments as domain knowledge to the large language model. So with this approach, the large language model is not only going to be able to know which columns each table have, but also it's going to filter out columns without comments. Because sometimes I have tables with hundreds of columns. You don't want to pass all columns to the large language model. You want to use only those like necessaries for the user's perspective. So in this case, you provide comments. So if you go to the Beaver, for example, you can select any table here, like the geolocation. Okay, now I'm going to find this error here. That's interesting. Yeah, same here, right? Probably I need to create some extra users to do it. Yeah, wasn't expecting for this. So, okay, let me see. Yeah, we can either like provide other different users for this case, or right now I can just limit the scope of it. So okay. See, basically. Yeah, probably I should like create different user for every one or something like that, because otherwise it's going to get this error here. So
Do you have access to the Postgres config file on the Postgres running this server?
No, not really. I have the Docker container that I created, but no, it's run from a Docker container here. So. Okay. Do you know how to do that? Can you help me, because I'm not familiar with this, so yeah, wasn't expected. So that's the container here. if I can like docker run interactively, and that's.
I looked it up too.
Oh, thank you.
So that would be the path on the container.
Okay, so how do I locally? How do I run?
If you use VS Code or Cursor, you have the Docker extension installed.
I cannot run it directly from the.
You're in. Right? Is that it?
No, I'm in the AWS machine here. So. Yeah.
So if you run Docker container on your Mac, right there.
Yeah, on my Mac here.
Right there.
But it's not in my Mac. That's something that the Docker container is all living on AWS. Here is something else.
Okay.
That's not work. Yeah.
Let's try then. You have a database host, so maybe we can. If it's behind a proxy, you won't know how to get.
Yeah. well, so I think I have an idea. So basically, yeah, I need to either provide increase the amount of connections allowed. So in order to not skip the tutorial, we're going to have a break soon, so I can leverage the break to fix it up quickly. But in the meantime, I think can some feel like disconnect on it, so I can like connect again, just like running here and disconnect. So I'm not going to use it directly right now. So. I can also ask ChatGPT how to do it. Getting like, let's try it. Yeah, that's not copying here. So. Yeah, let's see if we have something here, otherwise. But interesting is connecting. I think we can move forward. What I wanted to show you, I can like fix in the break time. But what I wanted to show is basically okay. Here, properties. Okay, it's going to take some warnings, but you can ignore it for now. And I can disconnect. That's not a problem, because in order to query, like we connect and query and disconnect, so that's fine. So let's move forward. Getting the comments, adding the domain knowledge to the large language models using the comments. So basically, that's what I have done, and asked the data engineers to do. It's like providing information about the column in the table. So every table, every column has a comment attached to it. If it doesn't have a comment, we're going to ignore this column. So that's the way you approach to dynamically filter out specific columns. So I can check it later. Okay. So like get columns, we expect the columns. Get foreign keys, we expect. Okay, started having the error here. It's like too many. So let me do something else here. Yeah, I'm going to fix it in the meantime. For now, I'm going to run locally here just to not give errors. So please wait for some break time so I can fix the amount of users error. So. So, okay, so our focus our goal is not to focus much in the database side, but it's important to know how we retrieve information automatically from the database. I know that if you search for chain, length graph, llama index, we're going to find specific tools to connect to the database and also to retrieve information more easily. But they don't have like domain knowledge. And that's a pretty easy way to get it like right off the bat. Like we retrieve both the context, the schema, but also the context of the tables. So why we need to have like you spec the columns, spec the foreign keys, the primary key, sorry, and also the foreign keys here. And then we have for this table, we don't have that's the primary keys. We don't have foreign keys. For this second table here called order payments, we have primary keys and also have foreign keys. So I just need to structure it somehow so I can use it in the database. I can create a vector database out of it, right? So basically that's how we do it. But of course I don't want to hard code everything here. So what you can do is like just copy and paste some of these database connections information. So we can jump to notebook 0.1, and here we have the load, the connection coming directly from Postgres here, from this connection here. So what I have done here, again, I'm not going to focus on the database, okay, people. We're going to have some hands-on, interact hands-on in the line graph section. But just to let you know how it's structured, so the package is called, it's structured like a package called like NL2SQL that have different modularized approach. So everything I'm showing the notebook, I'm copying and paste and improving it a little bit, adding doc strings, links, and so on for the modularized approach. So if you go to database, I have created like two files. That's called base. And basically, that's not, I don't want it. Basically, what I want to have is like, I'm not sure, have someone put dates here that's not expected. No. So basically, I have established here a pydantic model. How many of you are familiar with pydantic? Okay, pydantic is just a pretty nice way to start some classes with like predefined attributes. Well, it checks the typing annotation for us. Something should be string, it makes sure it should be string. Same for list and so on. So it's a very powerful way to control the typing annotations. And also, other than validating, we can access these attributes instead of like a dictionary that we need to use the brackets and pass the string. You can access the attribute directly, you know. So I can like access, once we instantiate it, you can use .host and going to find the host and so on. So here I have created this data parameters database, parameters class, pydantic class. And what I want to have is like a SQL-based connector that you need to do some things. First, set up the parameters. So it's going to load the whole support database, username, password, and so on, and establish the connection. And also create a way to provide the URL for connecting to the database. That's all I want basically here. So I have created this function to resolve the parameters. That's basically takes an order of prevalence here. So I don't want this here. Order of prevalence. So here we get the host from the direct parameters like the priority. If you don't have like a direct parameter pass here is none, it's going to take from the config file that I have mentioned before, YAML file. Otherwise, it's going to look for environmental variable. If none of these works, it's going to return none, right? And it's going to fail. But I have different options to set up the parameters, and then we can just create the URE and create the engine. So that's the base class that we have. And then based on this base class, you can inherit from this. Here we're using the ABC abstract method that forces the user to implement these functions here. So the user, for example, if I want to create a PostgreSQL database that I have done, I should create a function called create URE, and also should create a function called create engine. So I create an engine with SQL Alchemy. That way we can implement easily more features. Right now it's only working for PostgreSQL, but if I want to work for MySQL, for example, we can do it, Duck database, and so on. So it's easier to implement. So right now it's only implemented the PostgreSQL connector. And using this file, we're going to upload in the class here. And then I'm going to paste all the variables. It's not, I think I have asked them some suggestions, but it's not. That's when some AI messes up our code instead of helping. So that just happened. Just happened here. So let me see what is going. What is the error? So okay, let me see the database parameters. Okay. No, I don't want this here. Okay. Let me try it again. Okay, here you go. I need to update the GitHub later because I didn't know the AI made these suggestions. So here connecting to local. Again, I'm going to fix it in a break time. Again, the same thing that we have done before, we can do it like directly here. Just provide a simpler and effective way to connect to the database, and can also like use the inspector and inspect just like before. An inspector getting directly from the connector that I have created. And basically exactly the same thing that you can run like before, but then we took it from, establish the connection kind of automatically, right? And then you can provide a bunch of examples here. Just like given a query, I can read it directly from the connector.engine. Just like object-oriented approach here. Okay. So basically, this way you have passed by the database connection. So let's spend the last few times to understand how to create the data dictionary and also some SQL examples for the database, right? Because we want to create a vector store with information. Here, most importantly, for information about SQL examples. So let's go for this notebook called 1.0 data dictionary. So again, we're using just not using any kind of a modularized approach, just using the original functions from the library. So SQL Alchemy, we provide here. You're going to change the host and password. Going to load a base model here, and basically, perhaps like too much this part, but okay. I'm going to pass a little bit fast for this part since it's not our goal. But what you want to have, we need to expect like before the columns, the primary keys and foreign keys. That's essential for the SQL database to work. This text to SQL system, right? Because the large language model needs to understand it, and basically, but we're not going to provide unstructured data to the prompt. We need to format, to take the tables, columns, and format in a nice way so the model can understand it easily and don't also provide like a bunch of lines and unexpected tokens and so on. So we have like different ways, multiple ways to do it. One of the ways that I have thought on working with this is using column, like special identity classes to create a representation of the column, create a representation of tables, and so on. So when you create like thing like this, expecting the name, special description type, primary key, and so on. And here, yeah, I think it's too complex to go directly here. From the database, I have created. You can create a method that should return the database directly from the inspector class. So based on the inspector, of SQL Alchemy inspector, you should create this identity class directly. And that's like a common approach in Python. From, not sure if you have used like scikit-learn, that from estimator, from blah blah blah. That's how it works. You basically have a class method that we're going to use this function to establish the class, to create their own class. So it's going to take their own class that's going to be created based on something. In this case, the something is like the inspector of SQL Alchemy. And it needs some variables about like what is the table and schema that I want to get the information for this table specifically. Okay, so I'm going to jump a little bit because just like basic Python here to organize it, but basically it's like let me show you the output of this directly. So the goal is like, given a table, given a inspector in a specific table, you want to have all attributes of the table, and you can also format for the contexts. So let me show you a table info. So this table info is a PyDent table, so I can just show how it works directly here. So that's how it's structured. So we can retrieve the name, we can retrieve the schema name, we can retrieve the description of the table, what are the primary keys of the table, what are the foreign keys of the table, and then what are the columns of the table. So in the columns, you have the column class, where you have information about the columns, like name, type, if it's primary key, yes or no. Foreign key is most important in description. Description is going to be really important for the model to understand, to have a better understanding of the domain knowledge. Perhaps for this database, not true, but for real-world database, it's quite important to have domain knowledge. So based on all these attributes of table information, we want to have like format contexts to format this information so I can populate the prompt, right? So, and here it is. So I have the table formatted, the column formatted as well. And here I can provide different ways of abstraction. So if you want to have a representation for the whole database, you want to have like this hierarchy, right? The database, what are the schemas? Inside each schema have the tables, we have any table have the columns. And then you can have a main representation of the database called like data dictionary that I'm calling here, where you can also from inspector and from all the implementation can provide these. So basically it's like creating attributes and formatting all these attributes in a nice way for the model. So for example, here in the config file, I have some important files. Like one of them is the database that I'm going to take it here. It doesn't necessarily need to have the password here. If it doesn't find here, it's going to look for the .aim file. For the schema, here we're going to list every table and columns that we actually want to use. And the data dictionary is going to use this file here to create the attribute that it showed and also format it in the way you want to. So basically, it's going to take this file and create the database here. So basically, that's the file. I just load the file here manually. See, that's the representation of the YAML file. That's exactly this. That's the schema, database, table, columns. I have another schema here, and columns as well. So I'm going to use this file to create the whole knowledge that we have so far. So here it is. So here we have like that. That's the prompt. That's how we're going to populate the prompt for the file. So it's kind of, there is pros and cons of populating all these schema to the database, to the prompt, because we're going to have like more tokens and going to consume more tokens, right? But on the other hand, have you're probably going to have a better accuracy because we're going to provide like better all the relationships possible and all the domain knowledge the model is expected to have, right? So that's how we do it like manually. Since I modularize it, this like copying, I can copy and paste this file. If I go to the notebook 1.1, if I copy and paste these files, we're going to have something like this. So from our package, it's going to increase like incrementally, right? So in our package called like NL2SQL, have some config that's going to load the database, this YAML file here, and also going to load the schema YAML file there. Have the database connector, and also the data dictionary that's shown to you in the previous notebook. I can pass by it quickly. And that's just for like printing a nice section here. So what you need to do is like to load the database config. Let me show what it is here. Okay. Oh yeah, because I'm taking these here. It's failing. So let me go back to localhost here. Yeah. So basically, I load the environment file, right? I have the specification, the credentials here. I pass it here. Again, not necessarily needs to have a password because it also takes in consideration the environment variables. And then we can have access the parameters of the connector and also see if the inspector is available as well. It should be because you're going to use the inspector, you're going to use the engine of the database connection. And you can also see the parameters of the connection here, like I have defined before. So in this case, the local host, I'm going to fix it soon, and the password here. So basically, that's to showcase how it can do. So basically, on the database, that's the original schema file that I have. And based on the class that is implemented, we can create it from inspector and pass what is the database schema that comes from that YAML file. So we're going to look exactly for these tables and columns and databases. So you can just show it like data was created successfully because then shows what are the database and for the schemas available and how many tables you have in every schema. So basically you can have access a bunch of information from this object here. Again, object-oriented approach. It's going to be helpful to reduce code later on for our code. So you can also dump, show how it works like the database. This exactly the same permutation as before. So I can just use here access, for example, from the database. I want to connect from the available database to this database, this schema, and from the table, like this table here. And then here I can access specific information about tables and columns and so on. And most importantly, I have a way to format context for any of these attributes here, right? And that's what we need to do. So these are just like extra functionalities that we have. And talking about tokens, that's an important cell here, because tick token is a library that allows us to compute the amount of token given an embedding model. And for this, the most recent OpenAI models that I'm going to use here, it uses this O to 100K base here. This is the one used for at least for the ChatGPT 4.1, 4.1 mini. So I can expect how much is going to cost only this prompt here from the database schema. So that's got interesting. So let's say that's the price per query based on the OpenAI price right now that I have looked at recently. So it's like $2 per 1 million tokens for 4.1 and $0.4 per 1 million token for the mini, the 4.1 mini. And that's the price for one query. But let's say 1,000 queries. So if you're going to run 1,000 queries, the cost of this specific inclusion of the database schema is going to be $4 per 1,000 queries. Of course, we'll have the extra cost for the remaining tokens of the tools, the responses, and so on. So just like for the input of the model. It's quite acceptable given the use case. You can also play around with cheaper models if you want to. And then you can just fix, save the files here, save the database dictionary. So I'm going to save it in a folder called knowledge. So if you go to this folder called knowledge, originally this folder, not knowledge, database, knowledge. Okay, this file here was created right now. We don't need to have this file created. It's created based on this function. So that's what we're going to use for load and automatically populate the prompt based on this. So that's the original file. You're going to take it, format it, and put it on the prompt. From the SQL examples, these here so far it's like manually done. So I have created like examples of queries. So this was an example to populate the vector database. and basically have like a question and a SQL example for every main kind of tasks here, basically. By the end, we want a vector store that has a question, has several documents, and every document has a question and a SQL code. This one we need to like manually again. So again, like data dictionary was just created by our code, and a SQL example was just created. We created manually, and you can also basically ask some help for data engineers, so on, to improve the accuracy. Of course, we need here like complex queries better, like to help the model to understand the specificities of the current database schema. So that's it from the data dictionary. I'm going to have hands-on quickly about the link graph agents, but you just need to have, let me close it all here. So for the SQL examples here, we have that file that was manually created, so we should create it beforehand, and just need to load it and create, understand it. So basically, that's the file that we have here. So I have loaded the file, like the YAML file, just loaded it. If you use the same structure, you can use the same code for your use case. And then we need to format the query somehow. So basically we have the query, and then we format it using SQL parse. That's a library that automatically format the syntax for us. So you format and also provide like this special like code style approach. And you want to do it, you want to like populate a vector database with these examples here. So okay, questions and formatted example is going to help us. That's pretty straightforward, not much to be doing here. Again, the same path, just modularize it. So I have create a special SQL example class that you can discuss it later if you want to. But basically, just to load this file and to format this file, just like the data dictionary. So like SQL example load, what is it? So SQL example load from the YAML file, one function, and another function to format for prompt. And that's all you need to populate a vector database, basically. Here you can create a new example to add new examples, and can load, can save the YAML file, and so on. Okay, no SQL agent yet, right? Just creating I have one more notebook for setting up the vector store, then you go for the SQL agent. So this notebook here called vector store, we can, here I'm using, we need that to create the vector store, like number one. You also need to create the vector store and populate it to make sure it's working, the connection is working okay, right? So in order to populate a document, I'm using LangChain. So LangChain here, like I said, I'm using for just like prompt management and open large language model calls, like OpenAI. I'm calling direct from LangChain because since we're using LangGraph, it has a very well, it talks pretty good with LangChain, and you can use Langsmith to track all costs and debugging and everything from it automatically. Just provide a key in the environment file, and we're all set. We're going to be able to track and visualize everything. That's why I'm using LangChain instead of calling directly OpenAI, right? Because I can track costs and execution easily. So going to use the same implementation that I have done. So far I have implemented like a config file to load the schema, just like load YAML file. That's it. That's easy. Then I have establish a connector specific for PostgreSQL's dialect, and I have created this like kind of comprehensive, a little bit complex, perhaps overly complex data dictionary class that provides pretty nice way to work with the data, to turn our database in a data dictionary that you can manage as the way you want to. And also a very simple SQL example, just to load them a file, save it, and add new examples if you want to. You're going to use these functions. And here I'm going to use the PG vector from LangChain Postgres. Just heads up about LangChain. LangChain, if you go to their website, just to understand a little bit of this structure, it has several packages. LangChain. Yeah. So it has different frameworks and platforms. So, and from the LangChain, you also have LangChain is a library that allows us to connect to large language models. It has a bunch of functionalities to manage prompts in large language models, and also it tracks some costs and so have metadata. It's pretty good for working and orchestrating large language models. And LangGraph, it organizes graphs of execution, just like I showed here. Like to create this node-based graph, you're going to use LangGraph. LangGraph is going to orchestrate all of this. So every node here is going to be a function. And LangChain, it has multiple packages because the core of LangChain is quite lightweight. So it's not pretty lightweight, not heavy at all. So I can install it, but then have like LangChain community, LangChain Postgres, can have several brands of LangChain. So the user can install just what they need to, right? So they don't need to install like a bunch of heavy dependencies to tackle everything when they don't need to. And that's one of these extensions. That's another one. So I have OpenAI branch, so they can connect to OpenAI functionalities, and Postgres as well. So I'm going to use the Postgres functionalities that has this PG vector, and going to create. We just need to pass the engine. You need to specify specific model. So actually, let me do this here. And can create a collection database here. When I do that, if I go to this, that's the local version of that's the same database, okay? But that's running locally, that's running in AWS, and that's a little bit have a bug in it. So next minute I'm going to fix it. But what we have here, have like these different tables. Let me remove this all. Right, delete. So let me run this again. So I just like instantiate the class, right? We're passing the collection name called natural language to SQL embeddings. When we do that, we can, let me refresh here. It creates automatically these tables for us. There's like a reference table, like I have like this, the table name. And here I'm going to have all embeddings from our model. But since we haven't populated any document yet, that's empty. But our goal is to populate documents here so I can implement a RAG approach, right? Retrieval argument approach. So I'm going to retrieve from this table here. And I'm going to use this functionality from LangChain, from LangChain. And basically, I can get some documents here. Let me see. I'm going to get the documents from the data dictionary here. So the data dictionary, if you remember, if you recall, it has information about all the database and schemas available, and you can just instantiate it here and use this function that for every table, you're going to populate the content in a document LangChain object and the metadata. And for the metadata, I'm providing like the type, or its schema, and so on. Even though I'm not going to use the schema for this, I'm going to use a static version. But if you want to create a RAG approach for the for retrieving the tables directly, we could do that. So let's run this function here. So this function creates like some documents for every table, and then we can do the same for the SQL examples. So for every SQL example, we're going to format it using the class we have implemented, and add some metadata. The metadata is going to be like the type of the document's example, and this data title is going to be the name of the question. Oh no, sorry, it's going to be the kind of the ID of the question. So if you do that, you can see how it's here. So like retrieving like one example, that's this here. If you want to see the page content, so that's how it's done. So far, we still don't have anything here. If you refresh, nothing. But you can just use the LangChain functionality of add documents. You just need to create the document from LangChain. That's created like this document, page content, the content of the document, and metadata is open. You can use whatever you want here. Like this is like for our own use purpose here. In case to filter, you can filter by metadata if you want. So if I add here and refresh it, I'm going to have these tables here. So we have embeddings. The embeddings coming from the OpenAI embeddings model that I have selected. I have the content. It's called a table called document here, and I have the metadata. And I can filter by metadata as well. So I have some documents relate to schema, some documents relate to example, and I can retrieve based on some metadata keywords here. Then in order to perform a similarity search, I can just run any query, take the user query, for example, that's the user query, how many others with review greater than 4. By default, it provides the 4 most similar examples, and those are the examples here. Of course, it's good to evaluate the model. I'm not evaluating right now, but this I have from all possible files, those are the most similar ones. It can also provide the same thing, but using a score approach as well. So it can also provide for every document to have like the similarity score here. Okay. So actually, it's like the distance score. So basically, if lesser is better here in this case. And that's if you would have done that manually, you would have done that exactly that way, right? But if you want to use to modularize it, so far I have imported everything like before, but I added a new function that's coming from this file here, the vector store. So from vector store, I have created a class called vector store that it gets the connector, the collection name, and also receives the embeddings in case you want to pass a specific embedding. By default, we're going to use these OpenAI embeddings here. And you can like add documents, get documents from data dictionary, can get documents from SQL examples as well. So this class is able to retrieve, to get some documents from the data vector store directly, right? Let me just see here. And most important, we have like this add documents part here. They're going to use it since we provide like the vector store itself. So like the vector store is a PG vector. You can use this class here to leverage all link chain functionalities from PG vector, including similarity search. That's our goal here. That said, that's how we would do it using this class directly. So here I'm using the vector store from our implementation here, like I'm using this other collection name here from demos, and I can, let me try now. I can provide, for example, to read the SQL examples, to read the data dictionary directly that's loaded, and then get a document from vector store. So here I can show, for example, like it created 11 schema documents based on these here, getting from the store, and then you can access some content from a specific document, the first document that we have here. You can also create from the SQL database, same logic. This will get it from the same examples and add it to the database. So I have like 17 documents. The only difference that I have implemented here is that I'm using an ID for the document, so I can overwriting the existing document in case we have the same ID. And the ID is based on the content of the document based on a hashing approach. Right? You can use the same thing, like exactly the same code. This way, but from our class, we access the vector store from LangChain. Then you can use similarity search with score, without score, and everything here. And you can also filter by metadata. For one metadata that's common in all document files that I have provided here is like the type. It can be either schema or example. And that's a little bit of the boring part of preparing the data for our text-to-SQL, because in order to create a text-to-SQL agent, we need data, right? Organize and structure data on the vector store. To make it easier, I have created this file here called, I have a bunch of SQL scripts here, and that's a good, I like the structure of like project. I have like the modularized project under like the name of the project, in this case, natural language to SQL, where I also have a script folder that calls a bunch of functionalities implemented in the core functionalities of the package of the project. And one of them is just like set up knowledge base. So it's going to call all these functions, like for creating the dictionaries, loading the examples, populating the vector store, and it's basically all good to go. So what I'm going to do right now is just make sure it's like empty. Right. To delete. I'm going to delete so just to show that how it works. So showcase it. Okay. If I go here and refresh, I don't see anything. And then we can from the Python, we need to activate the environment, right? So just make sure the environment is activated, like .env bean. The comments are a little bit different from Windows. Then you can use UV directly. If you use UV run, it's going to use the environment from the project. It don't need to worry about, it's going to detect automatically the environment and run in this environment. So I can like run, scripts, setup, knowledge base. So let's see what it does here. And here you go. So I have created everything currently. So let's see if it's working for you here. Refresh. Okay. So here we have the tables, and in the modularized code, I have created specific IDs based on if it's a table, it's like schema dot table. If it's an example, have hashed the content of the question. So every question has a unique ID. So in case if you want it, if you change it, it's going to overlap here. And with that in hand, you can start playing a little bit with LangChain and LangGraph. I think you can, right now it's like 9036, you can have break up to 10 to 10, 950. Does it work for you? Okay. So, yeah, thank you. So, hands on.
So it's not like on my head.
No, it's not around. That's from the database line. That's right.
So shall we start again? Just to let you know, I have updated the specs on Docker in the AWS machine. So I believe it's not supposed to block anyone right now. So you can try to connect again, and you can try to run the scripts. That's fine, I hope. And so far I have also set up the the size of the, like, to increase here, like,
Make it more contrast or increase the font.
okay, this is
Like this, but that's
yeah, it doesn't difference.
Control plus.
Yeah,
Like
like this. Is it better? Yeah, welcome. Yeah, of course. So in the connection that I have shared with you, and the database I have shared with you, now I have these tables. I just connect to it and updated the credentials and run the setup underscore knowledge base.py from scripts folder, and here are. So I have our data that you can retrieve to help the model with the answer. So next step, we're going to use the notebook called like 4.0. And you can also like code along. Let's say I'm going to have a small task for you as well after this notebook here, so I can try with your own nodes on LangGraph. So like I said before, LangGraph is this orchestration framework that allows us to develop these highly complex graphs if you want to. Doesn't need to be complex, but the most important thing is that it provides us control of the code. So way more control of the code. So it's really nice. So because we have like we have a different kind of agents. We're talking about AI. One common pattern is called React agent. Have you heard about React agents before? So let me see if I have a good picture about React agent. I think Hugging Face has a nice picture about it. Yeah. Okay. Basically, React agent stands for like reasoning and acting agents. Where the large language model are provided with tools are never. It's just like Python functions. In the case, if it was in Python, just like functions, specific calling to functions. We call like these tools. The large models can reason about the user query and decides if they need to use a tool or not. So it use the tool, call the tool, get the output of the tool, like gets back to the prompt, and reason again. So now, based on like this output, do I still need to run the same tool, another tool, and so on, in order to provide the answer to the user? That's a really interesting approach. Pretty cool, way simpler to implement as well, but doesn't provide so many control about what's doing. So we can use LangGraph for implementing React agents. In fact, we're going to do it for the chat, for the chatbot. But for the SQL agent, since we have like a pretty, well-structured way of the graph. Like you want given a query and user, you want to generate the SQL, you want to validate the SQL, you want to ask for the user if you should execute the SQL, and then based on the reply, we execute it or not. So it's a streamlined process. So we don't need to use React for that, and therefore going to have more control over the code. So for that, we're going to use LangGraph. I'm going to show how it works, basically. So the most important part that I think is always going to load when using LangGraph is like from langgraph.graph, you're starting this function here called state, because LangGraph is a stateful project. I'm going to talk about it as the stateful approach. I'm going to talk about it. It works by states between nodes. And a start and end that indicates where the node should start and where the node should end, basically. And these here are just like for creating a nicer way from LangGraph to keep adding new message to the new message. I'm not sure if you know how large language models works behind the hood, under the hood, but the way it works is basically concatenating messages all the time. So the large language model doesn't have memory like human memory. The memory is based on concatenation of previous messages. So when you're talking to ChatGPT, for example, you have like, how do they know in the same session what I talked about 3 to 4 message before? So it's because it concatenates every call, it concatenates all the message and sends the prompt again. So it keeps concatenating and sending. Of course, in the long run, it generates some problems. We have different ways to mitigate like long prompts because of this history. It's not the goal of this presentation. You should not expect a really long message here, because just like you're going to call the bot, ask the questions, then start a new session, basically. But in case you want to, all of these ways to mitigate it and to understand LangGraph, LangChain Academy, it has a pretty nice course about using LangChain. So if you go for like LangChain Academy, it has this LangGraph course, agent course here. This course here called like Introduction to LangGraph. It's very complete and tackles a lot of things. Another course that I think is a really good combination with LangGraph with overall agent approach, the agent course from Hugging Face. So Hugging Face agents. This AI agents course. So of course they are going to use their own library, but they also mention LangGraph here. And they also, of course, they mention the course of LangGraph because it's very complete. But so yeah, so I have some good resources to study it. But let's see how it works like for our purpose here. One thing that's needed is like a state. We need to create a state that can be a SQL agent. We can name it as the way we want, the state. It can be like SQL agent state, SQL agent, chat state, and so on. And I'm going to use from PyDent, since I have been using PyDent from the whole project, I'm going to use PyDent here. Not necessary though. You can use like type 3, data class, different ways to have it. And basically, what you want to have in this state, it is all information that's required for the graph to run successfully end to end, from the first message to the end of the graph. So you need to provide some attributes that are going to update as long as we advance in this graph in the nodes. A classic thing like that's going to have like almost always the messages. For our use case, you want to detect the intent, because if the intent is SQL, you go one way. If it's chat, just small talk. Another way, want to have the SQL that needs to be executed. It's good to have the status after like checking for safety and syntax, checking for the feedback. Use the feedback status for the human in the loop approach. In LangGraph excels in it. Implement a really easy way to implement human in the graph approach, and also the final SQL result, like the interpretation of the generated query and execution. So basically, here going to implement give some placeholders here, so I can just see how this graph works in practice. So I'm going to create a function for detecting, classifying the user intent. We're going to detect to create a function for the chat agent. What should it do? For the SQL generator, validating the SQL, validating the syntax. For the human feedback, executing the SQL, and for analyzing the needs to be updated here. For analyzing the results, right? So that's one of the things that we need to do. Another thing, let me just show you. That's so I place a placeholder for all functions we need to have, but you also need special functions for the edge of the node. So I have like this is basically the node functions. Every node is a function here in this scenario, and for every node, I also need a kind of another function to tell which way we're going to get based on the status of this query. So, for example, based on the state that we're going to receive, I'm also going to receive the state. So that's we input state, we're going to output an update for the state. So for this router here, so after the intent, you want to route for either chat or SQL. So here I need to check if you like SQL generation or not. I'm going to have different routers here, and that's how it works here. So we start defining the graph using the state graph and use our class. Our class has special attributes that's only for our project. And then we need to add all possible nodes. In this case, I have already added all nodes for this particular project that I want to have. And then I'm going to add the edges. So the graph is going to start with the start. That's a placeholder for the LangGraph start. Then going to the intent classifier. That's the first node we're going to execute. Then from this node that I'm calling here intent classifier is going to use this function to route to either SQL or chat. So if the output is this function SQL, it's going to route to this node here called SQL generator. If the output chat, it's going to route to this node. Then we need to keep doing it for the other nodes as well. So for the SQL generator node, I have this function that's going to access. If it's a success, it's going to route to this. If it's a failure, it's going to route to the end directly. And the same things for the other approach. So you can start simple later. So we provide all edges, and then we compile the graph. Since we compile the graph, you can display it and see how it looks like. I haven't executed this here. So basically, that's the graph that we have just designed. Okay, and that's a pretty complex one. You can start simple, but like starting, like that's the start of the graph. So that's a node, a function here. Then have the special edges here. Let's go to the first See, that's the edge. So add conditional edges for these coming from this node here, intent classifier. That's going to provide either SQL chat if SQL goes to SQL generator. So let's see if that's the case. If SQL goes to SQL generator, if chat goes to the SQL agent, and so on. So it's kind of a bit complex graph. You could perhaps unify, combine some functions. You can have a node with more features in the same node. You don't need to split it up. But in this case, I want to have the most of the control that I can have here, as much as possible, at least. So one thing that you can do to inspect it before moving forward, I'd like you to perhaps compare if your colleague, just to create a simple node. He's a little bit complex, but you can create a simple node without implementing the functions directly. We just would like you to test for a while to create a state. You can leverage this code, right? You can leverage this code for 4.0, but you just need to create to load it, get state, and then you can use for every purpose. Let's say you want this one to have the tutorial. Let me think about something here. I think I'm going to leave it up to you. But the goal here is just to create a state with some attributes. And I'd like you to create a function that, given a start node, we go from 2 possible ways, and then can finish the graph. So let's try to get it done. And I'm going to move around to help you. Are you good? Do you want to do this task? No? Should I move forward? Or probably? Okay. Hands up if you should move forward. Okay. Okay, so I can do it with you right now. Okay, I need to do it together here. So ideas of a simple graph based on SciPy. Do you have any ideas that we can develop here? So let's see, SciPy state, base model. Then the message is kind of important. You can have the message here. And I'm going to leverage this code here because it's kind of the default way to have it. Basically, what I want to have, let's see. Users vote. So basically, I want to have a node that says, that asks exactly what I have just asked you. Should it continue or not? So one way to do it is like user vote is going to provide, let's say, should continue. Boom, go false. No. So I want to have a graph where we get the user's intent, if they want to have continue or not. If you continue, you're going to have hands-on. If not, we go for the continue the presentation. So hands-on or not saying hands-on. So hands-on. So that's one function that's going to start the graph. Let's see here. Workflow SciPy state then workflow. I'm going to add node. Let's add a node here, like voters, and then good. Okay. So that's the most basic form. If we want to create a graph, so we start, we add, first we instantiate all nodes again, then we start combining, making the connection. So it goes from start to this function here, and this function matches to the end directly. That's how we start creating these graphs, but then we need to create more. So for example, def should continue. That's a routing edge. So then def hands on and def I think that's fine. So right now we can start creating some conditional edges. I have some good suggestions here as well. So we go to the function users vote. You apply the should continue function that's going to return either yes or no. If yes, it goes to the hands-on node. Otherwise, it ends directly. And then you can also add hands-ons, go to the end. And let's see how it goes. I need to add and instantiate all nodes. And here you go. So yeah, that would be the task that I would ask you, something like this. No, you create like one function, the input function, some kind of conditional edge, and then something else. And that's how you start drawing these graph applications. So instantiate all functions available that you want to use and start making the connections for them. So from start here, from here, I'm going to apply the function that's going to map which way to go. And occasionally, you should always hit the end of the function. Okay. So basically, when the user is calling the large language model, is calling application made with LangChain, every message is going to go direct from the start. That's the usual pattern. So hi goes to start, and it's going to be here. How are you? And following up questions goes from the start as well. So how do the model know about previous interactions and so on? Memory. So I'm going to create some memory database memory and store this memory in a database. Can be local, it can be in Postgres. Here going to do in Postgres, and it stores the previous interactions. And it's always like augmenting the prompt with the memory of the previous interactions. But it's always go from end to end unless we add some specific interruptions in the middle of the graph. And that's where the human in the loop comes in. So the human in the loop can, for a specific graph here, node here, you can add an interrupt function from langgraph, and then it's going to wait for some feedback from the user, and then it's going to start directly from this node instead of starting over. But only this scenario. By default, every message goes to start and runs all the path to the end. That's how it's done. So let's move to the next notebook. So this notebook is kind of the same implementation of the previous one with some extra functionalities. And I just talked about the memory, right? How is the model going to be, since like it always starts here and ends here, how do they know about previous interactions and they are able to connect? Basically, memory. You can have like short time memory, it's kind of session-based memory, and also, you can also have, not implemented here, but it can also have like long-term memory. That's a feature, a cool feature for ChatGPT, for example. Like when it stores some memory about our personal information, personal like style and preferences and so on. So that's when you see that memory predated. That's something, that's a long-term memory. Otherwise, the memory is restricted to the session. So far, I'm going to create a memory that's restricted to the session as well. So to do it in LangGraph, that's the pattern use. We need a dictionary that has this key configurable and have a thread ID. And that's the session ID. So the session ID is going to come from probably from the UI, the way you interacted with the model, right? Then you need to have some combination with it. It can be like user and so on. For this example, just like using a random test with the current date time of the execution of this notebook. So the same state, but we start implementing base scratch functions like mock functions, just to see if it's going to work as expected, and also start adding some logger information. I start logging just to see if it's going to the path I want it to go. So this logger, I'm just providing like, okay, that's an intent classifier. It just hit the intent classifier, and the way I want to retrieve the user query, let me say user message. Basically, I'm going to have to take the last message from the client. It's always going to be the last in this case because just starting the node, since it's just like starting the node, the message is coming from the user, right? So you can estimate it. User. Can assume it. So in this case, just like if it has this pattern, like /SQL, is going to route to the SQL. It's going to detect the intent as SQL, just mock, that's a mock based, and otherwise that's chat. So that's to make sure it works. For the chat agent, it's good to provide run answer right off the bat, just hello, how can I help you? It's going to be hard-coded right now, just on this message. If it's not SQL based, it's going to provide this message always, right? For the SQL generator, I'm going to mock SQL code here as well and provide it directly here. For the SQL validation, there's a very simple validation, just seeing if you have any kind of drop or truncate statements in the application, in the SQL code, sorry. Then you can also validate the syntax. Perhaps you could combine, like validate SQL validation as a whole, so validate both the safety and the syntax. That's also fine. Then have the human in loop. So right now I'm hard coding like approved. You can like randomize it later, but okay. And for the SQL execution, I also provide mock for everything, basically. But the thing is, I'm debugging everything just to make sure it was working as expected, right? I'm providing all these handful and helpful messages. Here you have the analyzer. So also the same thing like for route intent, it should provide either SQL chat because it's going to use this to define which way to go. Same thing for the our other route options. So far I'm also hard coding some of these applications. then instantiate all nodes, provide all logic here, and you can test it out over here. So let me restart it and do it here. Okay, so that's the same graph, but now I have some message. So I can simulate, for example, a chat agent, because I just said hi. I didn't provide like this special character here, like / SQL. So it should go for the SQL approach, or for the chat approach, sorry. And it is, so like it hit the intent classifier, it detect like chat, it wrote into chat, and also it went to the chat agent and provided answer. And if you do the same, but if SQL, then it has a way longer log responses here. So it detects the intent classifier like a SQL, and then it went to the SQL generation that's generating a mock SQL code. Then it went to safe validation that it's saying hard-coded like it's safe. It's also saying hard-coded like it's safe, it's valid. For the human feedback, we haven't implemented yet the interrupt option, but for the human feedback, we should ask for the human, and based on the human approve, you're going to have either approved or denied. And here we go for the SQL executor. Execute the code and analyze the code. So it's a bunch of all large language model callings here, because these here are going to implement using a very small large language model to detect if the user intent is either SQL or chat. So we're going to use like a ChatGPT 4.1 mini. That the cheaper is pretty reasonable, pretty powerful. You could use a simpler model for doing that as well, for sure. I just decided to use the same API key for everything here. For the SQL generator, you're going to use a large language model as well. In this case, depending on the complexity of the database, usually it's good to have like a good model here, mainly for like complex queries. You can also route, increase a little bit more the complexity in route based on the complexity of the query. If the query is like just simple, use like common SQL parsers, detect the query is very simple, we go for a cheaper model. But if the query requires a lot of joins and so on, then you can have use like a better model for doing that. Here you don't need a large language model. You can validate it directly with Python functions and SQL-based knowledge. For the SQL syntax, Postgres already provides a way to check the syntax for us and provide error. So in this case, we're going to use a large language model to fix the syntax in case you have a specific syntax error. So it tried to validate it, it failed. It's going to have failed for a reason. Then you can use the large language models to take this failure message and also the original query and update the query and try it up to 2-3 times, for example. Then human the loop, no large language model here. SQL execution, no large language model here, just like SQL alchemy to executing the query, and also the node for analyzing the result. And here we need a large language model again, so we can so they can interpret and answer for us, summarize and provide the final answer to the user, right? That's it. How do we get the state? So here we have, if I run here, like invoke, that's the pattern of lang graph. So you're going to invoke, we can either pass a state directly, or you can pass a message here, like a dictionary. So a dictionary if common keys between the state and this dictionary. So basically for every node, for the nodes that has the actual implementation, not the routing, but the node itself, not the edges, right? For the node itself, it should return a dictionary. And what LangGraph does behind the scene. So what LangGraph doing is like making a pair comparison. So given this key, the LangGraph is going to predict the existing state with this value where this key matches. So LangGraph goes to predict the previous known, because here we start with known, like a non-valid value. So it's going to predict this key with this value here. In this case, is approved. That's how we keep changing the states across the nodes. And I haven't detailed, but LangGraph, one of the things that they provide for us is like specific classes for messaging. You can about human message, AI message, system prompt message, and so on. It's not required, but it's good to have it because it helps the model and also helps traceability of this application. So good to go. The graph, I forgot to say. So how do you get the latest stage and everything? So basically, we can get the last state that's running. It's based on the memory. We can get using this function here, like get state, and then we provide the configuration variable. That's the dictionary for like configurable, thread ID, and the session from this specific session here. So for this specific session, that's the values that I have. I have like a state snapshot, and you can also get all available history of these variables here. So you see like it started, then after starting, right, the first call that I have had. After starting, it went to the intent classifier. It was classified as a chat. The AI message, we get a response for the AI message right here. I have the class of the message. Then I read it again, like I started over again. And now the human said like SQL. And if you go forward, it went to the intent classifier. It was like provided all the state, update the state accordingly. It was moving forward the process and was updating the process. So first, you don't need to debug it like this. I have like a nicer platform to do that. Langsmith to that. I have like the platform for LangGraph as well that we can host it locally and helps us to visualize it. But it's all based on this. Like on the hood, that's the history that they provide. That's how this platform is able to track it all. So let's proceed to a way more complex implementation, basically, for the whole project. And I'm going to detail some of it, but also I'm going to test some specific states so we can like familiarize with the code. But in this case, it can, since it's a large application, can become a little bit complex, but it doesn't need to be. But in this case, it is, because we're doing a lot of things, like a lot of validation, a lot of steps. So here I'm loading a bunch of all the nodes. I have implemented the functions directly here. I'm going to discuss it right now. And also some utility functions as well. So I'm also going to discuss it. And one of the important things, we have discussed everything you have discussed prior to the break, right? The PostgreSQL, data dictionary, vector store, and so on. This here is new. So I have provided some utilities to execute the SQL query, format it, and get chat history, and so on. And also go for load some prompt template chats. So in order to make it easier for anyone trying to update it, leverage this code and update it later, all these prompts, all the main prompts at least, is like they are provided as configurable variable file on the prompt. So have configs, the configs for the database, configs for the schema that you want to create in the setup knowledge base, and also the prompts. And here have all the instructions for running this the application. So for intent classifier, you have the system prompt and user prompt. Just a reminder, system prompt is the special instructions that you pass to the large language model. You pass it only once, and then you can interact with the passing some user prompt. So basically, special instructions that you pass to the model is like system prompt, and then the user prompt is going to be the user message based on it. Basically, if you have ever paid like for Cloud AI or ChatGPT, you have these, or Gemini as well, have these like special projects. In the project, you can provide instructions, and I'm pretty sure they use something like system prompts there. That's the instructor to read it. Okay, so not going to read it all for you, but it's basically like instructions, right? You can take a look later, but basically for the intent classifier, I'm asking the large language model to classify either SQL or chat. I provide like a kind of few short example about if the user is greeting, help, asking for help, general conversation, and so on, go for chat. Otherwise, like it's asking for some keywords, some terms about SQL, please go for SQL instead. I have some examples here. For the chat, I have hard coded right now for some like over information about the schema, just like the tables that I have available for every schema. And also I have access to tools because I have created a React agent from the chatbot. For the SQL generator, so also what do you need to have here? We need to have the schema context. So far it's like hard code is a static based on the setup that I have done. For the SQL example, this is coming from a RAG approach that I'm going to show next. But I just provide the top 3 or 4 most similar query examples, and then also provide the chat history for that session. So that's how the user can ask, like I showed in the beginning of the tutorial, like show me all the properties in state A from Brazil. What about state B? So you understand based on the previous interactions. That's talking about state and farms and so on. For the SQL explainer, this is a nice tool that's not required. But if you go to the chat model, if you want to large language model to explain, please.
How are you passing the schema information to the model that's invoking this prompt?
Yeah, that's good. I'm going to show it right now, like in a few moments. But so far, it's everything here that's like in curly brackets is just a placeholder, and the logic behind how I am populating this placeholder, I'm going to show in the next stage here in this notebook here. But everything here is placeholder, and I'm populating it somehow. I'm going to show it. And then I have the queries, the prompt for the syntax validation as well. Because like I showed, I'm using Postgres directly to access it. And if it doesn't work, I'm retrieving the error and ask the LLM to fix it for me, up to 3 times. And finally, the analyzer. Okay, now that's a lot of prompts, right? The analyzer and the SQL. I think that's legacy. I'm not using this. Let me do. Move. Okay. I'm not using large language model to validate the SQL, or I am. No, only for the syntax. Okay, but how I'm like populating everything. So let's restart and go from here. Upload everything here. Right now I'm just like creating set a connection to Postgre database and it's inspecting, loading the vector database. It's already populated, so I already have all files over there. I'm creating a memory. It's in-memory session. So this in-memory session is pretty easy to implement, but it only lives while this notebook's up. So if I restart the kernel, it's going to lose all memory because it's in-memory based, right? But it's quite easy to change it. LangGraph makes it quite easy to change, connect to Postgre, MySQL, SQLite if you want to have something local, but that keeps persistent. So that's good. So same thing here. Here I'm loading all the chat prompt templates from these. Let me copy this part here and answer your question. So how are you going to do it? So basically, I have this function here that loads the prepped shown template, and it's quite straightforward. It just like loads the YAML file. It's going to have like the dictionary. That's a dictionary of key and values. It's loading these here. So let's take the intent classifier, for example. It's loading the intent classifier. I have a key called system prompt. I have a key called user prompt. And then I'm creating this chat prompt template using LangChain functionality. So just like load the dictionary and pass here. So I pass like the string, right? From message, I create a system prompt that's come from the YAML file that I have just loaded, and the same for the human. So the human, I'm going to take the user prompt. So that's the prompt. That's the way I have provided it. So it creates these. It creates placeholder. I haven't populated yet the placeholder. But let's say I want to populate it. I can call invoke. And then I need to pass these keys here in the values. So let's say, let's leave it empty here. We don't have chat history in this example. And for the user measures, you can say, how many customers do we have? So hero syntax, invoke, chat. What is the syntax error here? I'm not finding. It's equals. Oh, it's not a dictionary, so it's like this. I forgot how. But it says like a syntax error. I'm missing to find a syntax here. Oh, yeah, that's right. It's not a dictionary here. Okay. Yeah, thank you. So basically, it provides a template chat prompt value, where I have the message, and I have the message for the system prompt, and also for the user. So I can, for example, start inspecting it. So I have the messages. So I have a list, so that's the list I have. So in this case, I'm only populating the human message. So I can take the content and also print it. Yeah. Yeah, so this here was populated from this. What's cool about it is that we can instantiate a model, let's say, init chat model, like chat. Okay. We can create a model here like this. I can provide any kind of model here, not only for ChatGPT. If you want to specify the provider, it's smart enough to detect the provider, but you can specify the provider model, the model provider here, and we can add chains. That's why lang chains called lang chain. So I can provide like prompt, intent, classifier, prompt. Put invoke LM. So I can create this chain here, like LM chain. And then here, instead of providing the here directly, I'm going to provide these, and let's see the message. Chat model. Let me see what's happening. What happened? Okay. Here provided the output of the large language model directly. So I just removed by accidentally the definition of length of these here. So yeah, so that's how we connected. You use invoke to connect everything. They can unify the prompt with the large language model and take the content directly here. Because I'm using print here, so I need to do it here. It's written in SQL because of the system prompt, right? The system prompt is asked to provide either SQL chat, nothing else. Good, that's working what it's supposed to do. And you're going to leverage this pattern that I just showed you for many different nodes. This kind of chain of prompt and large language models. So let's deep dive a little bit in the nodes. So the first node, we're going to get the chat history. So this function here I have defined as utility. In just simple as concatenating the messages and providing the user the role. So since we're using LangChain messages, like either human or AI message, we can take the type of the message, it's either human, system, AI, and then the content, and just structure it and provide a single string instead of list. So, and I'm missing intentionally in the last message because the user here. So I take the chat history. In the first run, it's not going to have anything here, but in the consequence call is going to be populated. For the user, I take the last message from the state. Again, in the first time, we have only one message, so the last is the only one. Here, provide the model, just like I told you. I'm using the temperature pretty low, like 0, because I wanted either chat or SQL, nothing else, not to be creative here. And then I'm using this route. The router is intent classifier in large language model, just like I showed before, and invoke using these messages. And then I'm going to get the response of it And just some common checks here. Just make sure if not chat or SQL, it's going to fall back to chat, but it's not supposed to happen. So I'm going to leave a warning here just to let, probably you need to optimize the prompt or something like that, because it should be one of them. For the chat agent, for now, in this notebook, like pretty straightforward. Not working with the chat agent right now, just fixed response. You can even change it here. So I can only help you with SQL query generation for your list. Okay, let's hard code the chat agent here. For the SQL generator, so what I have implemented here is basically, again, get the history to make sure, like, it's important to get the history in the session. And then I'm formatting the context using this, the variable that I have created in the previous section. So it's just like an object that loads the YAML file. The YAML file were created in the setup, during the setup environment. It's going to load this knowledge file here. What is it? It's going to load this and format it in a structured way. Then it's going to format it for a large language model, like a very nice way, like table, columns, and so on, like concatenated. In this loading process, we're going to, in the setup process, we ignored all columns without comments to optimize to not having more than needed. And then that's for the schema context, and for the documentation, for the few short examples, here I'm using a RAG approach. So I just have the vector store that I have defined before, and I use a similarity search to find the user, the four most similar examples according to the user query. In here, I'm filtering for example. I'm only returning the four more similar, only related to SQL example, not a table itself, because for the tables, for the schema, I'm already providing here. And that's something that you can optimize it if you want, because the user message in the stories is not always clear for the large language model, because let's say, like the first query that I have done, okay, how many farms do I have in Pará, in Brazil? Then it's going to answer. That's a good question, valid question. But then in the next interaction, I can ask, what about MT? That means Mato Grosso. How is the model supposed to know about it? In this case, it's going to leverage the story. It can help. It helps, actually. For so far, it's working. But it can also ask the large language model to redo the question. Based on the history, redo the question, then it populate. You take this question that is refactored for large language model. It's one approach to improve even further the accuracy of the model. So far here, I'm using all ChatGPT 4.1 mini for this tutorial. I recommend using like a good model for. Of course, you need to test it, but I would do is a good model mainly for proof of concepts. It's the first time you're going to show it for your employees or the team, so on, like just make sure it's working good, then you can optimize it, costs, latency, and so on. Then it's going to invoke. It's going to replace all those placeholders with the actual text that I have retrieved here, organized here. So the user query is coming from the state, and the chat history is going from the get history function, schema context from the YAML file, and the examples for the vector database after formatting for the large language models. You can also add some extra key validation here, but it's optional. Okay, what about the validation? Validation is quite straightforward. Like I have in the config file, I have this key SQL keyword that I don't want to user to run it at all. Then, if you have any kind of word, if this word is present as a word in the SQL, I'm not going to allow the execution. I'm going to leave it. Here, just like I'm logging the error. I'm looking for the error. I'm appending the unsafe word keyword that was found. And then I'm providing the message, this state here. It's unsafe. If it's unsafe, our router is going to route directly to the end of the message. It's going to finish with a message, in this case, this AI message here. So SQL contains unsafe keywords. But you can also show to the user if you want to show the query, so they can inspect the query, right? That's the query, but we're not allowed to run it because of this. For the syntax validation, I'm going to use this validate SQL syntax here. And in this case, I'm using this prepare command from PostgreSQL. So that pure PostgreSQL syntax here. Just like this validates the query, like validate, prepare, validate SQL as, so it validates the query for us, and then they allocated this validation statement. So you don't need to implement it ourselves because it's already implemented on Postgres. We just need to run it and to capture the error in case we have an error. In case we have an error, if you don't have an error, it's going to leave this loop and finish this node. Okay, the query is valid, and that's the current query. So go ahead. Otherwise, it's a loop of like 3 maximum attempts. So for every attempt it's not correct, it's going to use the prompt for fixing the syntax. So I have like the SQL syntax fixer here. That I'm structuring the model to fix it, basically. And I'm providing the error, the original query, and asking it to fix it. If some specific like informations here. So it tries to fix it, update, like every trial it updates the value, and then it goes over and over. And the way I usually test it, of course, like so far it's like all dumped in this notebook, but it usually tries specific state. Like I can start from a specific predefined state. I don't need to invoke every time I'm testing the LangGraph approach. I can create like a specific state with like mocked SQL code, mocked state for attribute for the state class that is necessary to reach the desired behavior that I want to observe here. Then I use this function directly. I don't use LangGraph at all. Just use this function with the state, and I can see how it's performing. Okay, try it up to 3 times. If after 3 attempts it didn't work, I didn't reach out of this project, but then it's going to provide a message. And it's going to provide like syntax is false, actually it's invalid, right? Let's see. Yeah, actually invalid. It's going to go for invalid. So the router is going to detect like the output of this. It's going to check for this attribute here. In case invalid, go directly to the end and shows the message to the user. Finally, you have the human feedback here. So that's a really good question and approach to tackle the problem. In this implementation, I'm using it's not as smart as you suggested. It's like trying to fix it, it doesn't get it right, then try to fix again, using the last code provided, but it's not using any kind of history here. We can do that definitely, like trick a little bit this function to do it. Yeah. For the human feedback, let me go, before showing that, let me go direct. I can keep here. That's from other thing I was testing with Slack, but didn't have time to make it work for now. So basically for the human feedback, we have these two special functions of LangGraph. That's called LangGraph.types.interrupt, and also command. And with the combination of these two main functions from LangGraph, we can implement him in the loop quite easily here. Basically, we add the interrupt function whichever place we want to add it in the node, and it's going to stop. Or in this case, it's going to stop. It's going to wait for the user replies. When I say user reply, technically speaking, it's like the next invoke. So it's going to wait for the next invoke with this special command session feature. And then when you do this next invoke, like capturing the user message, is going to return the message into human reply here. It's going to start using from here. So it's quite impressive how it's that easy to implement here. So basically, the first thing I need to provide the answer. So I'm format. I have this function here, format answer, that takes the state. It's basically just formatting the SQL, showing like the SQL, getting the SQL, format it as a SQL. For example, if you want to use in Slack or Stringlead, any kind of like markdown parse UI that understands markdown syntax, it's going to format like nicely for us. And then it also provides some quick explanation here based on the explanation. That's all of this is generating during the generate SQL generation code. So I take it, I format it, I show it to the user, and also adding these questions. So should I execute this query? Answer yes or no. That's for our like interactive approach here, but nicer ways to do it is like using buttons, using like any kind of UI that you can use here. Then it can become quite more complex, the code, but we can use UI elements as well. So we're taking the message, you're going to show the message, and you're going to interrupt it, showing this message here. So I'm returning this. I'm going to, in the code, I'm going to have the last state is going to be interrupt state with this message and this special state here. Actually, I'm not using this. Actually, it's just like inspecting directly from the state if the current state is interrupt or not. If it's interrupt, I'm going to in the next reply of the user is going to go directly to this part here. Then this provides some kind of cleaning. It's approved in case like there is a Y in the response. That's pretty naive approach right now. You can improve it, but just if it's it's yeah, anything like that, it's going to recognize as approved. Otherwise, it's not approved. Then it's going to return again a message in the human reply, and in the feedback status, it's going to update the current state, right? Final execution. So since it passed all the steps, it's confirmed by the user. If it's approved, it's going to go to this node. Otherwise, not approved, it's going to finish the graph. It's going to show the message to the user and finish the graph. Here, the next step is providing the query execution. So I have this utility function here to execute the query and just basic SQL alchemy code here. So just I'm using the connection, the basic connection that I have here, and yeah, I'm gonna like execute text query. So then I retrieve some kind of information. By default, it provides like a very special data frames. That's like a list of tuples, if I'm not wrong, a list of tuples, but it doesn't provide the columns. So just like providing, wrapping up with data frame and redoing it as a dictionary where I have the column information and some extra information as well. So by the end, what we're going to have is like either like a suffix, if it's true or false, the data, that's going to be a dictionary, pandas friendly, the row count, if there is any error, and just like the executed query as well. So that's what are going to be here. And it just said if it's like succeeded, we keep it like success, otherwise like failure. And it just like provides some log information. That's done. Right? We run the query already, and we have the data that's saved in the state of the graph. So the next step is just take it and pass to a large language model again to interpret it. So I'm not sure. I have asked some help the large language model, but it didn't help at all. I'm not sure what it's doing here. I need to see my previous comment, but okay. That wasn't me. Okay. Just check here. Okay, it's going to copy the execution, the result. If data is not known, it shouldn't be known, because if it's known, it's not going to go to this node at all. So it's kind of redundant right now. I'm going to provide like to read it as a data frame. And then I'm going to provide this function here that reads the data. It's not that reads the data to the large language model. So let's see. Yeah, here. So basically, this function is going to take the dictionary, and if everything is okay, if you have like if we succeeded, if we have data, get it to a pandas data frame, provide some text about it, and going to also limit some kind maximum rows and columns for the large language model to analyze it. You can provide it as a string, and then you can provide a string, can provide as a markdown as well. And then that's the formatted data that we have. So information about the data, structured information. So I just need to pass to the result analyzer. So instantiate the model, make the chain with the prompt, with the formatted, with the original user query, of the executed user SQL query, and also with the query results, formatted query results. Then it should have our response. So just take it and return to the user, and we're good to go. So let's try to see in practice. That's the rotors. The rotors kind of straightforward, like just telling which path to follow. And the same graph as before. So let's see. Okay, so that's the same graph, but now I have implemented all our functions the way it should be. And we can invoke it, categories here. So we have different ways to invoke. We can invoke directly from a dictionary, where we have like the human message, or we can invoke directly from state as well. That's up to us. So let's see. Okay, there's error, vector, store. Okay. Let's try to find it out. Oh yeah, because I have implemented this later. So basically what I want to do is just, let me show you quickly here. Just to let you know, by default, like at least at the best of my knowledge, LangGraph only, they accept like these specific node functions to create the nodes if they're receiving the state, but in order to pass a new extra argument, the way I'm doing it is using a partial functions to apply it directly. And one of the things that I have developed beforehand is the connection to the vector store, because I don't want to connect and disconnect to the database every time the user asks a question. So it should be connected once, and then it's connected, right? It just use that established connection. And also another thing that I haven't done in this specific tutorial, but we should turn every function here asynchronous, for def async, instead of just defining the functions. So let me just check how I have done it here. And okay, let me, I'm given the error of not finding the vector store. It's missing the vector store. Okay, so I'm going to do it directly here. Let me. Vector store. Okay, I'm having another error here. Let me see if that's the actual name of this table. Okay, let me do this. Okay. Okay, so here you go. For example, I have asked for what's the most popular product categories, for example. That was my first question because I have just restarted the kernel here. And here it shows all the way it go here. So Yeah, sorry. The problem was for some functions here, I was asking a specific parameter. Let me see here. Yeah. Some of the function I asked the PG vector store and also the database connector, and I didn't have like a default value for them, so I changed the default value for these functions. For the vector store, the functions requiring a vector store, and also for the functions requiring a database connector. So that's what I have done here to fix it. I think this notebook, the next one's a little bit more complete and less prone to failure. So let's try to understand what's happening here. So I have, along with this function, I have provided a lot of logger information for us to understand what's happening under the hood. So basically, every time I have this node on the brackets, it's hitting a node, and this blue message here is like the debugging track of the inside the node. So we went to the intent classifier node, and then it retrieved the history. First message, no history, that's fine. So the last message, that's the message for the user. The detect intent, so SQL, so it's wrote into SQL. Next node, code generation, provides the user query, the length of how many messages we have in chat. In this case, I don't have it, just the user message. Retrieve 4 documents. So far, it's hard-coded. The reg approach is using default length chain value. It retrieves 4 documents. The most similar documents. I'm going to use these as an example to teach the model how examples. It's wrote into success because it was generated the SQL code. Then went to the validation section looking for drop and update statements. It used the Postgres functionality to validate the syntax. No needed to fix the syntax here. And then it went to the human feedback and it stopped. It stopped because it's waiting for the human feedback to reply. So, and you can see that this special value here means that we want to, it's expectant for something. So what you can do if you grab, for example, the current state, like get state, and that's the snapshot of the current state. Every state has a value called next, and it's going to show the next value. So the next value is going to the SQL execution. So it stopped right before that. So we can use these when building the API, the chatbot interface to check. Like we invoke, but not only always invoke directly. You need to have a check to see before calling the invoke, because in case it's a human message, you can detect using this pattern here. We are going to use the command approach and resume to a specific message from the user here. So let's say the user is saying yes. So we're going to send it back to invoke, but using this command here. So it's a combination between interrupt inside the node and command in the invoke or the vocation of the graph. So let's do this. And I also have connection error. So basically the same here. Let's go. Okay, same thing. Let's go here. And now it's running here. So let's see. So I invoked, and it went directly to the human feedback loop again. So it went here, it continued execution this time, like it was approved, it's routing to approved. So actually it's routing to SQL execution, right? I need to put the log here. It's using the approved route to the SQL execution. And then it's executing the query, executing this query here, and it's returning that log file. It executes successfully, returns 74 rows, even though I'm limiting the maximum amount of rows to 10, I guess I can improve it, I can increase it as well. And also providing some like responses, the SQL result as a list of dictionaries that we can easily like read if pandas data frame. And then we went to the analyzer, and here just finished. So usually, in my experience, the analyzer takes some might take some time depending of the query. So here's the current, the last state. So I have the message, our collection of messages. Have the user query, the user intent, the SQL query, the simple explanation. The result has the status, successful or not, true, the data that's going to be used to interpret the results and provide the final answer to the user, and the analysis here. So that's the analysis of this product. We can inspect it. Okay, I haven't saved, but I can get the last state because I have used memory. So graph get state thread count. Thread counting values. I went to that's the answer that I have. Okay, so that's the answer provided by the model. So it shows like for instance, the top 5 products. It has some business context insights, key patterns, possible actionable insights. It's like too much, too verbose here. We can just like show the result and some basic explanation. The way we'll change it is prompt, right? Prompt engineering, because we are providing like user query, the SQL, the original, the executed SQL query, and also the data. And then we ask the model what we want them to do with the approach. So if we go for prompts, we are asking kind of a big deal for the model. So basically, we're asking like what data shows in business context, key pattern, trends, and insights. So based on this query here, the system prompt, the model is generating everything. But you can nail it to your like user case. So I just want the data, straightforward, go for it. If you want to explain, you can also provide any other ways to explain it as well. Yeah, so changing the prompt is going to change a lot the result. For example, we can also test it, let's say, like return only the result as a string. The results be concise. Okay. So that's the power of the prompt engineering, right? If you change here and just execute it again, I'm going to see a different message. Okay, so it runs like the most popular product categories are cama, there's a banho, bed, bath, and table, and makes the translation between Portuguese and English, and just lists it directly. So now we're going to have this all in the notebook, but you're not going to productionize the notebook, right? You need to make it an API for it, create an API for it, and also modularize it, like start copying, pasting all this content to the correct paths. So that's what I have done in the source, in this folder here called agents. So in the folder called agents, I have created nodes with all the implementation of the nodes I have just discussed. The only difference is going to be the chat agent that I haven't created a notebook to explain it, but the chat agent, I can explain later, right? Let's jump it just for now. But the chat agent is a React pattern. So if you go to the chat, then it's going to use these tools that I have created to provide extra features for the model. And the tools is quite easy the way, just like Python functions. So just create a Python function with a good doc string, and you empower the model. As simple as that. I have created a function to return the most similar queries. I have created a function to explain the detail, the SQL, or also to get the schema information, where you can add anything they want here. You can also use like predefined tools from other third sources, right? Most using MCP, for example. So that's a whole world of possibilities. So all node code, the same for the notebook is here. Let me see if I have anything else. No, the routers. So that's the nodes. For the state, I have created here a state section. I'm also provide like a session for storing the session ID in some metadata that you can use it for. Even though I have not used in this particular tutorial this session, but it's good to have a session class in case you want to store some, not only ID, but some metadata, for example, the user. That's something pretty cool to make in Slack, because since we're receiving the message from Slack, we can capture the username in this like special format from Slack and answer, like mention, like personalize the response to the user and so on. That's pretty cool. And I have the graph session here that I'm creating, and this graph. And I'm actually creating the workflow here. So I'm importing the nodes here, and what I have all the nodes functions that I have specified. I also need to import the state and the connector, database connector, and the vector database. So like I said, I'm using the connecting to the provide the connection directly to when I load the graph, and I do it only once. I'm not going to do it inside the nodes because I don't want to keep creating the connection all the time. I do it only once, and then I create the workflow exactly as it is in the notebook. Then I'm going to return it, but not compiled, only the workflow. So I need to compile the workflow with the memory checkpoints. So that's the main brain of the core of the language tribe, the agent. What I have done here right now is let's create a really simple, fast API agent that you can call directly this model and make it run. So, for example, under the API folder, I have some roads in the main file. The roads, I have like two roads. That's the chat, that's the main implementation, and also the health, just a simple check of health of the API, so nothing related directly to the text-to-SQL approach here. But for the chat, working and managing how do I call these invocations. So here I'm loading all the features that I have discovered so far. Okay, except this here because I'm not sure exactly why, but Postgres doesn't. I didn't make it with the common SQL alchemy. So for creating memory using Postgres, if you go to the documentation of LangGraph, they recommend using like connecting directly from PySQL PG. So basically, I'm going to instantialize some patterns. For example, the database creator, the vector store, and then I connect. I have created this special function from our connector to the PostgreSQL. We just create a specific URL for the PostgreSQL. It's a little bit different because it don't need to specify like PySQL PG since you're using the PySQL PG library directly. So that's just a difference of how to build the connection string between SQL Alchemy and Postgre URL. And that's the function that you use for LangGraph to connect it. I'm going to use this connection string. And then this here should be run only once to create the memory. Right? So far, we don't have any persistent memory here in our database. If I go to the public, and see the tables. Yeah, apparently we have it, but I'm not sure if someone has run it. But I'm going to like exclude it and run it again just to make sure to showcase how it works. Okay. So yeah, once I run it, it's going to create it, the memory of the checkpoints. All these state histories that I have showed before, this very complex nested information, it's all going to be stored in this memory, and you can just like retrieve the messages and take the last message, for example, to get it. So these parameters here for the connection string also comes from the LangGraph documentation, and it works just good. I'm not exactly why the reason to pass it, but I just followed the instructions. It works. So I create a graph, and now I compile the graph using the checkpointer memory file. So basically, we create a graph using the connector, use the vector store, and in the checkpoint. So that's how you specify the checkpoint, and you don't need to any extra configuration from our side. So that's how LangGraph makes the things easier for us. So just like when you compile a graph, you specify a checkpoint memory that in this case we were using like in memory before. Now I'm going to use from Postgre directly, and every node is going to update every execution, every like run on the workflow is going to update the state in a persistent way in the Postgres database. So kind of almost out of time. So for the main chat agent, the API, you're going to initialize the components, all these database and so on, and then I'm going to provide some session. So basically, the session right now, since testing out, is based on date time string with a specific UID, so not needed, but okay. In real time, like in real world applications for a session ID, it's going to come from the UI interface, right? The user interface. So for example, for Slack, I usually use a combination of Slack channel and Slack thread, the responses for the specific Slack channel. So even though if a different user like keeps asking a question for a specific thread, it's going to consider the memory from the whole thread section from Slack, for example. So it really depends how you want to do it. Like, but I think the most common way is like user-based and session-based, like user and the session from the UI that you're using. So for now, let's test datetime. That's our approach so far. And you have gone from this, like the user message is going to request to take the message from that's an API, so it's going to take the message from the post request. And then you're going to get the current state. And this here, you're going to check, let me see how it works here. This here you're going to check this next attribute here that I have talked before. That's how you see if you have a next step in the way. You don't need to specify which step. Just if you have a next step in this specific scenario for our user case, it's like a human, the human in the loop approach, because you don't have other next step. So it's only going to be true when we're asking feedback from the confirmation from the human. So if you have it, then you're going to use the common approach to resume the request. Otherwise, you just make the invocation as usual with the state that you have in hand. Okay. Let me also show how this here works. Also, in order to test it, let me show it here. Let's try to make this API up so we can test it. We run API. Okay. So right now it's looking on my local host. So let's see. If you want to the documentation, so we can have, that's the chat. And that way you can integrate with any UI user interface you want to. Like I told you, like Slack, Streamlit, Gradio, custom React applications, and so on. So the health, just saying that it's healthy. Right, it's healthy. Database connections connected successfully as well. And for the chat, let's try it out here. Let's see if it's going to work. So the session ID is going to be like test123, and message, let's just start with some high message. Let's see. It's going to work. Okay, it worked. So in a real like chatbot message, is going to be like response directly to the chatbot, right? But it detected here like some metadata, like the users want to chat and so on. So let's ask a question about database. Let's see how many customers do we have? You can also see it executed directly here. Yeah, it provided the query and also answer like should I execute this query, yes or no. Of course, not formatted here because it's in the API response, but it's like if you pass it to Markdown, Slack or any kind of Markdown reader, it's going to be formatted. So And you can also see here how it's going behind the hood, like you look in the logs. Let's say yes. So yes in the session. Oh, okay. Okay, thank you. I was like, why didn't it run? Okay, that's why. I should like let go here and go here. No, it wasn't. So that's good. It's good because it didn't happen what we were expecting. So let's try it again. Okay, provided here the answer. So there are 96,096 users, unique customers in the data set, and that's the SQL has generated. If you go to the database right now, we can, let me refresh this. Refresh. So you have all these checkpoint tables, but the most important one that's automatically generated by the Postgres server when you instantiate it. But the important table here is checkpoints. That's the table that you can inspect and use for debugging, for providing extra information. And that's actually when you retrieve the history using LangGraph and get state history, for example, it's written out these tables here. So if you go in here, see that yes, that I accidentally put in the section ID, so it started creating a new like flow execution here. But that was not supposed to happen, okay? And then it has here all the steps. And I also provide the steps, like starting steps like -1, then have like the actual step from 0, 1, 2, and so on. That's a JSON blob file, so it's kind of long. I have a lot of information here in the metadata and also in the checkpoint itself. And in this column, we have the TS, and you also have the histories directly here. So TS is the thread, right? The thread are executing. The timestamp, sorry, TS timestamp, and have like a bunch of things here, unique identifiers and so on. But you can have like the message directly from here. And you can also debug it later and so on. So, but you see, we don't have provided much queries, and you would not have a lot of files, a lot of lines. So it grows up quite. It can get quite long here. In case, so from time to time, I think it's recommended to clean it up. In case not, you can add some kind of automatic like cleaning from this table in case it don't matter about having old histories. If you do, then keep it. Otherwise, you can clean the database. Since it's running, I have created another script that you can. Unfortunately, I didn't have time to create an UI and so on. You can try it. I think if you ask like cursor right now, it's going to create a pretty straightforward string application. You can try it. But I have created, it's right here, to chat, terminal chat. That the terminal chat, you can then have some kind of application as well. So you can show me the most what users let's say like how many distinct users have rated products over 4 least once. Oh, and failed. Good. Means relation to. Yeah, let me see. Let's try and chat failed, consumer input failed, served, close, connection. Why? Let me try to. Yeah, because in order for this to run, the API needs to be running, right? And then apparently it's working. Not sure what failed, perhaps. Yeah. So it provided, for example, the SQL execution, then count distinct customer ID, provide an alias for it. That's good, and also get the correct tables like order reviews, order customers, where other reviews bigger than 4. So apparently it's right. It explains. So should I execute this query? Let's say yes.
Can we talk about a little bit about this query? See, it's looking at the query that selecting a distinct user that have high ratings. And I was wondering, what would be your approach to improve the model to where it's reading the user intent just to better understand, generate the query?
I think that the way I would go for optimizing, for letting the model know more about the user and the domain context is mostly about prompt engineering SQL examples. So I would provide more examples about similar queries. So in the reg approach, it's going to retrieve the similar queries, and of course I'm going to provide curated queries for the way I want to do it. Like it's a combination about like prompt engineering for the system prompt, and also better examples for the SQL. But if you want to like go even more complex, for example, you can also implement some kind. I don't think it's needed, but you can implement some kind of long-term memory for a bit on user-based. So just like ChatGPT captures some information, some preferences, but user can also do that here. Like LangGraph also provides really good features for providing long-term memory. In this case, I have only provided short-term memory for the session, but also you can provide like long-term memory given the user preference, where they detect some kind of preference, and then populate the second memory table based on the user. And then you just need to update the prompt again to provide placeholder for this personal memory in case you want to. Well, that's it. Well, that's basically prompt engineering examples. I think that would be my way to go. Explain this query in detail. Let's see if the tool I have implemented is working. Okay. Okay, they apparently crashed again. I'm not sure what's crashing the application. It shouldn't be. Probably working, let's see. Okay, here you provide a detailed explanation about the query using something that I haven't shown you properly. That's the tool for the chatbot agent. So let me clean it up. So for the chat agent that I haven't talked about, just like a quick overview, I I have provided some tools. Like I said, tools are functions, Python function that you can provide. And then like the tools implemented here, I have used a class to do it. It doesn't need to be a class. It can have like isolated functions to work with it. I just provide a class because I'm reusing again the data dictionary and the schema. And just I want to do it once in this case here. But here, going to, for example, to take reusing the vector and so on. If I want the user to be able to list the most common queries, that's something you can ask. Going to retrieve the most similar queries as well, or explain the query. So you can add another call to a large language model to explain in detail the query. That's mainly for like education purpose. Let's say you have like a domain scientist. That happened to, in my case, a domain scientist who wants to learn SQL and also wants to understand, better the SQL and how it works and so on for our database. So I can provide this helper function to explain in detail the queries and why it was generated. Getting scheme information, and I think a pretty cool like tool that I haven't provided here that's going to be pretty useful for data engineers if they want to do it. Is just like, please log this other SQL example. So the user, like in the chat, provide an example of a question and an expected query. In the large language, it's going to use this tool to parse it, format this question, and add this document to the vector store. So that's an easy way for improving and adding more examples to the vector store. And from the chat perspective, from the graph nodes, and how do we make these tools available? It's also quite easy. So basically, you list every tool using this function from, I think that's from LangChain, sorry. So from LangChain, there are different ways to do it. One of the ways is like using structure tool, that we get the tools directly past the function definition. So it lists a list of functions. You need to have good docstring. So it passes like a list of functions with good docstrings, and then for the prompt, we can we create the large language model as we have done before, and then we create an agent. That also different ways to create an agent, but the agents like a React agent in this case, like large language models and tools and the prompt, and then we create an agent execution here. So this is really well covered to the AI agents course from Hugging Face. It's a pretty good one. I recommend. And then you can invoke as usual. So basically, like we instantiate it with these tools, and then it's going to automatically use the tools to apply this React pattern, like reason about the question, use the tools, is it solved? Okay, if it's not solved, use the tools again in case you have the tools available. It's way more unpredictable. That's why for this application like text to SQL, like we have a pretty clear streamline flow, it's better to establish all these nodes in order. But for other scenarios, it's easier to implement a React agent, and it's pretty cool as well. It's a pretty cool application to do, pretty useful. Bit harder to debug though and to test it. And so far I haven't provided tests, but it's good to have like unit tests. The usual way I work with unit tests here is like I test basic Python functionalities and also add an extra tag like large language models, that any kind of API call that you need to do that's like is a little bit slower and it needs to have like this special credentials for database or large language models, then I tag it. So for the custom, for example, CI/CD pipeline, I can only test the classical Python functions, but locally I'd run a test for the large language models using this tag and then using the credentials that I have locally in my computer. And yeah, I think almost in the end. So a lot of things, there are some questions and considerations that I'd like to do. Okay. Yeah, I can create like after a simple string-lit application to make this interaction more interesting. But other than that, I think that's all I wanted to share with you. Like for me, it's important to provide this core knowledge about the LangGraph because this project was heavily relies on LangGraph, and also to show the power of LangGraph as a whole. Because we also have like low code tools to do it. Have you heard about, for example, NHN? No. I think if I still have time, so I can. If you want to, it's a low code to create AI agents. It's quite easily, like 5 to 10 minutes, you can create something cool, but it doesn't provide as much as control as LangGraph, and it's not that good from production as well, but it helps a lot. And that's the power of LangGraph. I have different frameworks. I think LangGraph is highly recommended for building production-ready applications. Other tools. So for this orchestration, I have like low-code tools like NHN, Make, for example. For like Python frameworks, Hugging Face have their own agent implementation. I think it's SML, something with SLM and agent. I need to check it out in the course. We have a Llama index, more similar to LangChain instead of LangGraph. I have a Crew AI. Crew AI is a really good framework. I haven't played a lot of it, but Crew AI provides a way to create agents based on roles. So basically, I have a really straightforward way to create agents based on roles. So I have like the data analyst, the manager, and so on, and then we can orchestrate it with Crew AI. By the way, it's a really good, it's a really huge, famous framework, and it was originated in Brazil. Yeah, I think that's the one that I know the most. Do you want to have like a 5-10 minutes NHN showcase or haven't? Okay. So let's do it like it's pretty. Right, so let's say NHN Docker. I'm going to run from Docker directly, so I don't need to worry about. Okay, so let's copy and paste. You need to have Docker installed, right? Oh yeah, I think let me just check my Docker. Okay, let me stop. I have a lot of things running here. Okay. Okay. So that's the NHN. So if we want to create a simple flow from scratch, we can, let's create a shared trigger. Shared trigger, and then you connect to AI that has AI agent here. And then you can create an AI agent. So for the AI agent, what you want to do is getting specific information. So I want to have a system prompt where I have the specifications for the model, right? So let's take the specification for creating, generating the SQL agent. So let's leverage from here. Prompt. let's SQL agent creation, SQL generator, SQL generator, SQL generator. Here. Okay. I think it has some kind of special. Let's do. It's great, very so simple. So you are like an agent that translate questions, use dialect. That's fine. Session context. So this here need to paste. So let's go to one of the notebooks that I have, just to copy and paste quickly here. What is the data dictionary? I think I have got it. Okay, so let's copy this here. Okay, so far I've been hard decoding everything, like all the SQL examples here. And for the SQL examples, let's say just like analyze SQL examples from memory. I'm going to do it. Okay, so basically we have this agent with the system prompt. We need to connect a specific OpenAI model, any kind of model. Have a lot of options here. Let's say OpenAI. OpenAI. We need to establish a credential. Credential is the API key. Let's use the API key we were using before. Okay. ChatGPT-1. Okay. So I have already established the connection with the model. So I'm going to use this model. It can use memory and specific tools, but not necessarily needs to. For example, let's say, how many customers do we have? Oh, yeah. When you hit it for the first time, no, it's not showing right now, but when we hit for the first time, it's going to, oh, that's not here, sorry, it's this here. Here, like you can provide OpenAI credential. Like it was empty here, so I went to the create new credential. I just provide here I paste. Oh yeah, sorry, database. Yeah, that's good. And it's not going to work. Very good too. So let's go to tools. You're going to provide like, this is going to behave like a React agent, right? Instead of like the flow that I have done so far. Let me do something like just a simple knowledge. And just now I need to provide a credential with the Postgres, right? So if you go to the Slack, let's go copy these. User and oh yeah, database. Okay, good, worked. Thank you for the support. Oops, not working. Let's see what's happening. Probably here I also need to provide an OpenAI embedding model, just like I have done with the code side. You can use these here. And I'm still using the OpenAI account credentials that I have used. I can select different ones here. Let's take the same I have used. Then I have this tool. You can connect like multiple tools here. Now let's see if it's going to happen. Oh. Let's see if it's going to happen. If it's going to work right now. Okay, it also shows, for example, is executing the agent. Apparently didn't hit the vector database. Yeah, it didn't hit the vector database because all information needed, it's already provided in the system prompt, so it didn't need to get it at all. But let's say what about, I don't have memory, so it's not going to work directly. You can also provide a memory. So let's use a memory on the Postgres as well. Like that's the name of the table. You can keep it. And let's try it once again in a different section. So yeah, you see it now it used the memory, but it haven't used the SQL directly. And so far it's only providing what it asked to provide, this kind of JSON file, but it's not executing the query directly. And in order to execute it, I know that I would need to search for. I know you can do that, mostly for like some specific tools, tools that connects to that also reach the database. But I would need to check it out. But that's quite easy to implement, right? In this like just a few minutes, we have like created a very simple like prototype interface. You have linked the model. You could have linked any different model, and also establish a memory in connection to the Postgres database. If you see the column, it should be over here. So let's refresh it. So okay. Here you go. So it also has the memory here. So like ID of that's automatically created ID, like incrementally. The session ID is based on the chat message, and also having a message here. So that's an easy way to do. I'm not going to be able to have time to show how to create the query execution here, but that's another tool for you to know about. And it also shows the steps it has on here. So like over here and here and here. So in fact, for developing, when I was developing this text-to-SQL system from my current lab, I started with this. I started with NHN because it's way simpler just to showcase, okay, that's useful, that's how it would be useful, like to trigger some interest on people and then showcase that's possible, so they can test some queries as well. And then we went to the code side to deploy it properly. And that's all. Please.
Does this provide the same, like how LangChain provides the different nodes and everything? If I want to take a programming approach, can you still do that?
Yeah, I think we have some coding nodes. I'm not sure. I haven't tried out. I also have some human in the loop approach here, but it's kind of providing has a bunch of integrations as well. But just so about LangChain, actually it's using LangChain under the hood. LangChain is open source, right? So it's using LangChain here. So it's using LangChain, and we can provide some special nodes. For the code side, I know there is a node called code, but it's pretty basic. You can define Python, but you cannot like define, at least to the best of my knowledge, you cannot provide any kind of environment and so on. Probably you can do that, but I don't see it in my test here. What you can do instead, if you are a coder you want to use it, we can provide you can host an application, any kind of like webhook, and then you can connect and here have connection to any kind of webhooks. including like Slack and everything.
Thank you for sharing.
Yeah, of course. Yeah, thank you for listening to talk so much.